Namaste, dear students. So, how are you all? I hope you people are doing good. So, after a long vacation post examination, so this is the first online class which I am taking. As you all already know, that I will be handling quantitative techniques subject for this semester. So, I'm starting the first class e-class online class. So first lesson called indices. So I'm starting unit number 1. Unit number 1 is indices. So I'm starting indices. Indices. So that is unit number 1. So as you already know that it is based out of this subject is based out of mathematics. So I have already told you while explaining the uh, syllabus part. So and I also insisted you to keep a separate notebook so that you can maintain a notes and you can understand and you can learn also. Okay, so let us understand the meaning of indices. What is the meaning? So first let us understand meaning of indices. It is very simple if we speak practically. When if you say directly like number which can be multiplied by itself separately, and the result may be expressed in terms so many times of that number. So that means the value or a number involves a base and the power. So that is what we call it as a indices. So the value which will be expressed with the help of base and power combination is we call it as a indices. So there might be a question about this, what do you mean by indices for 2 marks. So if that is the case, your answer should be like, let us write when a number is multiplied by itself separately, the results may be expressed in terms so many times so many times of that number of that number you write in other words when a values or a number involves a base and and the power and the power and the power is expressed is expressed is expressed is expressed is expressed in terms of in terms of indices in terms of indices. So this is the ultimate meaning, simple meaning which you can understand. So we can also say indices in other way round also. So that is, if you get confused about these, and if you want to be more simpler version, so you can have this. The term indices is the plural form of the word index. The word index. So the plural form of word index is called indices. So for that we can have an example. So here I am going to give you one example. Observe it properly, okay? So observe the following examples. The following examples. So I'm giving one example for you people. 3 to the power 4. So here what is base? Which number is base? 3 is base. So base number is what? 3. And which is the power? That is 4 is power. 4 is power. So 3 to the power of 4. That is how you have to read. And how we express it now? So 3 to the power of 4 means multiply the base into number of power. Multiply the base into number of power. So that means abbreviated version of this is how many power? So 4. 3 to the power 4. So how many times I have to multiply 3? 3 into 3 into 3 into 3. 1, 2, 3, 4. So is that correct? So that is the power. Okay, 3 into 3 into 3 into 3. That means 3 3s are 9. So then you have to multiply again. 9 3s are 27. So again you have to multiply 27 3s are. How much 27 3s are? Yes, 27 3s are is 70. Yes, it is correct. 27 3s are how much you said? 81. Correct. So 27 3s are is 81. Suppose if this is the case, numerator numbers has been given, so that we did. Suppose if this goes like this, a to the power 5. A to the power 5. So here which one is the base? A is the base and power is 5. Power is 5. So now multiply the A how many times? 1, 2, 3, 4 and 5. So 5 times you have to multiply the base. Okay, so that is A to the power 5. Okay. So this is just to make you understand what is indices. I'm making an attempt to make you understand it clearly. Okay. So let us look into further. If you look at above explanation, above example, what you have understood now? Yes, that is in the above example, in the above example, the base is 3 and A is multiplied by the number of times given in the power, the above objective. So you can understand the objective. What is the objective? The objective of indices. Objective of indices is to simplify things. I believe now you have understood what we said in the meaning. When a number multiplied by itself separately, the results may be expressed in terms so many times of that number. So that is what we did. That is what we have explained here. In the above example, the base is 3 and A is multiplied by the number of times given in the power. The objective of indices is to simplify the things. Okay. So I believe now you have understood the important meaning, that is what do you mean by indices, correct? So now we have to understand the laws of indices, the basic laws. So how many laws are there? Have you heard about these laws? Do you have any knowledge about these laws? Yes, no? Okay, that is fine. So the majorly we call it like 5 basic laws, but other than that we have few more also. So now let us understand the laws of indices. Okay, the laws of indices. So laws of indices. Laws of indices. Laws of indices we are going to understand now. Okay, so now what is that the laws of indices? So what is the weightage of this? So 8 marks, 5 marks, 2 marks and 2 marks. So that is how the pattern will be divided for your question paper. So on the basis of application level also they'll ask the question. So 8 marks plus 5 marks plus 2 marks plus 2 marks. So this is the weightage of this application level of problem will be asked. So you have to learn this lesson. You cannot give reasons. So you have to learn nearly 17 marks. 22% of your question paper will be set from this unit. So you have to focus and you have to understand properly. Okay. So now let us understand the first law. First law I am writing, that is the law is first law. This is a to the power of m into a to the power of n. A to the power of m into a to the power of n. that is equals to a to the power of m plus n. A to the power of m plus n. You cannot expect all the time that they will give you multiplication symbol. So by this time you all know that even if there is a dot, that is also considered as a multiplication symbol. Clear? For example, I am writing it in a bracket. If a to the power m dot means multiplication, a to the power of n, a to the power of n. This is also means a to the power of m plus n. Okay, so dot is also considered as a multiplication. So when bases are same, powers can be added. See, a is same. So what we have done, when bases are same, this multiplication power, so that is adding. Clear? Addition, that should be added. When bases are same, the powers can be added. This is the first law of indices. First law of indices. I believe you have understood, but still write it down. When the bases are same, when the bases are same, then the power can be, what we did, can be added. This is for your reference. I have written this is for your reference. Okay, this is a reference. So now let us have one small example so that you will have a clarity about it. Okay, so let us go with one example. So that is example number 1. Example number 1 I am going with. When bases are same, powers can be added. So that is 2 to the power of 3 into 2 to the power of 2. 2 to the power of 3 into 2 to the power of 2. So that is answer. How now? When bases are same, powers can be added. So 2 to the power of 3 plus 2. How much? 2 to the power of 3 plus 2, that is 2 to the power of 5. Correct? So that is equals to 2 to the power of 5. So if you multiply 2 for 5 times, how much you will get? Use the calculator now. You want me to write and show once again? Yes, how to add you have understood, right? 5 times you have to multiply the same 2. Correct? So the answer will be, according to me, answer should be 32. How much answer? 32. If you are wondering how I got 32, let me explain you. 2, how many times power 3 plus 2 is 5? 2 into 2 into 2 into 2 into 2. 5. 1, 2, 3, 4, 5. Now multiply 2 2s are 4. 4 2s are 8. 8 2s are 16. 16 2s are 32. So my answer is 32 only. Understood? Easy, right? Yes. So this is first example which I have given. So let us take one more example. Suppose a to the power of 3 into a to the power of 3. A to the power of 3 into, dot is also called as into. So a to the power of 3 into a to the power of 3. So what is the answer then? A to the power of 3 plus 3. That means a to the power of 6 is the answer. A to the power of 3 plus 3, a to the power of 6 is the answer. I believe you have understood. Correct? You have understood? shall we move to the second law? Yes. Okay, so we are moving to the second law now. So this you have to learn, dear students. If you don't learn, you cannot solve indices. Without laws of indices, you cannot solve the problem. Okay. So now second law I am introducing. Second law. So what is the second law says? That is a to the power of m divided by a to the power of n. So this is over. Let me close it. The first one is over. First law I have already made it clear. Second law I am going. A to the power of m divided by a to the power of n. So what we are going to do here? So we are going to convert this, that a division will become minus. The division will become minus. So what we can do, I'll give you one shortcut. Okay, so here you make a note that here this multiplication will become what it will become? Addition. Correct. So here what is happening? Division. What I said, when division comes, so then when bases are same and the division is there, so then it comes to a deduction. So a to the power of m minus n. A to the power of m minus n. So when division comes, that leads to what? Minus. Make it simple, keep it simple so that you can remember easily. Division is nothing but minus. So here let us make one note also so that you don't forget easily. Okay, so make a note of this. In case of division, when the bases are same, powers can be subtracted. Powers can be what? Subtracted. This law can be applied. This law can be applied only when, remember this, only when m is greater than n. Okay, so you have to make sure m should be greater than n. Okay, so then only this law can be implemented. Okay, here also if you have confusion, what we'll do one small example so that you don't get confusion. Okay, so example problem, 2 to the power of 5 divided by 2 to the power of 3. 2 to the power of 5 divided by 2 to the power of 3. So now what you can do here, 2 to the power of 5 minus 3, because m value is greater than n value. So 5 is greater and 3 is lesser. So if you do that, how much you are going to get the answer? 2 to the power of 2. So now multiply 2 times 2 2s are 4. So what is the answer? 4. That's all. So if you still have the confusion that how sir we get 4, so if you have a confusion still, what we can do here, 2 to the power of 5, how many times we have to multiply 2? 5 times, right? Yes, right. 1 2 3 4 and 5. 1 2 3 4 5. Done. 2 to the power of 3, how many times I have to multiply? 3 times, correct? 2 into 2 into 2. So now find the answer for this. 2 to the power of 5, 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32 I got, divided by 2 2s are 4, 4 2s are 8. So now just check out how many times if you multiply 8. 8 ones are table, 8 ones are 8, 8 2s are 16. Yes, 8 3s are 24, 8 4s are 32. So 8 4s are 32. So 32 divided by 8, that is equals to 4. So this is your answer for this law, second law. So I believe you have understood. You have understood clearly. Okay. We'll have one more example so that you will get more clarity about it. So example A, example B I will write so that you don't get confusion. 3 to the power of 5 divided by 3 to the power of 3. So can you do it? Try it. That is 3 to the power of 5 minus 3. So that is equals 3 to the power of 2. Multiply 3 2s are, 3 3s are 9. Answer is 9. Correct? Answer is 9. If you want to give a try, give like this. So answer you are going to get 9 only. Answer you are going to get 9 only. So clear, students? Yes. So we'll go with one more law. Now I'm going for third law. So third law of indices. What is this third law says? What it says? When it comes to whole power, when it comes as a whole power, how we are going to do it. So that means A divided by B whole power m. So when this comes, when whole power is there, so this can be separately divided. Powers can be divided. So numerator and denominator, so whatever you call, A to the power m divided by B to the power m. A to the power m divided by B to the power m. Did you understood? Yes, no? Okay, I believe you have understood. A to the power m and B to the power m. So you want one example for this? Are you expecting? It's fine, not an issue. We'll go with one example. So example I'm writing 2 divided by 5 whole power 3. 2 divided by 5 whole power 3. So that can be denoted as 2 to the power 3 divided by 5 to the power 3. So now calculate. 2 2s are 4, 4 2s are 8, 5 5s are 25, 25 5s are 125. So answer is 8 divided by 125. 8 divided by 125. So I believe you have understood clearly. So we'll make one note to this. That is when bases are different, with the same power, the individual base will be raised to the raised to its power only, its power. its power. Okay, fine. So now I'm moving for the next law, that is fourth law of indices. Fourth law of indices. Suppose two different bases and there is a multiplication symbol, a into b whole power m, a into b whole power m. So if that is the case, so what we can do this as a individual power we will allot, that is a to the power m into b to the power m. That's all. A to the power m, b to the power m, because bases are different. When bases are different, so individual powers will be allotted. That's all. Okay, so if you want, if you get confusion, make a note. So note, when two different bases, when two different bases is raised to its power, raised to its power, the individual base is, the individual base is to be raised separately, to its power, raised separately to its power. So obviously you are expecting an example, that I know. So let me give an example for this. So two different ways, let us take 3 into 4 whole power 5. Yes, 3 into 4 whole power 5. So if that is the case, how I convert here? A to the power m, b to the power m. So 3 to the power 5 into 4 to the power 5. So now find the answer. What is that? 3 to the power 5 and 4 to the power 5. So answer like 243 into 243 into then 4 to the power 5, that is 1024. 1024. That means 4 into 4 into 4 into 4 5 times. Here 3 into 3 into 3 into 3 into 3 5 times. So if you do that, you're going to get this answer 243 and 1024 separately. So use the calculator, then multiply this 243 into 1024. So how much ultimate answer you are going to get? So let me check in a calculator. 243 into 1024, that comes to 2,48,838. correct? 2,48,832. So this is the answer you are going to get when you do this, when you solve this problem. Okay, so next I'm going to going for the fifth law. So the fifth law says, that is when two different power, like individual power and whole power is given, that is if the case is a to the power, I'll adjust the camera a little bit so that visible entire book. Okay. A to the power m whole power n. So if this is the case, what to do? M into n. That's all. M into n. The base remains same. So that is equals a to the power m into n. A to the power m into n. So now if you take it as an example, so as you all expect one example from me. What I'm writing, 2 to the power 3 whole power 2. So then what is your answer going to be? So convert first, that is 2 to the power 3 into 2. So first multiply this power, 3 2s are 6, 2 to the power 6. Okay, 2 to the power 6. So that is 3 to the power 6. Okay, so now we are done with the fifth law. So next I'm going to tell you about the sixth and the seventh one. So now I'm going for the sixth law. So wherever you get a to the power 0, that is always equals to 1. So you have to remember, when there is a 0 value, that is always equals to what? 1. So let us give an example. So I'll give you an example. 2 to the power 0 is always equals to how much? 1. Okay. So let us make a note for this so that you don't get confusion while solving the problem. Note, any number raised to its power, 0 will be always 1. Always 1. So you have to remember this. And seventh law. So what is this seventh law speaks about? So you're curious thing, right? Or you're getting how many laws are there, still how many laws we have to learn. A to the power minus m. If the power is negative, so then it is simple. You divide by 1. 1 divided by a to the power m. A to the power m. So if you have a confusion, let us give an example for this. Example, 2 to the power minus 3. So in such a case, what it has to be? 1 divided by 2 to the power 3. Correct. So now multiply 2 into 3 times. 2 2s are 4, 4 2s are 8. So the answer will be 1 divided by 8. Okay. This one, because it is a minus value, and this power comes down here. So 2 to the power 3. Multiply 2 3 times. So you are going to get 8. 1 divided by 8. So next I am going for the eighth law. When root comes. Root n a. So whenever root comes, it's very easy, guys. That is a to the power 1 divided by n. So if root is there, 1 divided by n. Okay. So example you want, we'll have one first example. Suppose say root 5. So for root 5 there is no any number, just root 5. So that is the case, 5 to the power 1 divided by 2 if there is a only root. Suppose if there is a 3 root 5, so that comes to 5 to the power 1 by 2. Sorry, 1 by 3. I'm sorry, 1 by 3. Suppose 2 roots are there. Suppose the root value goes like this. 4 root 5 to the power 5 to the power what I can give here, 3. 5 to the power 3. So if that is the case, your answer should be 5 to the power how much? 4 is there. What is the power? No, I cannot do this. What I'll do is I'll change it to 6. Okay, 5 to the power 6. So then power you write first, 6 divided by root value 4. Okay. These are the basic laws of indices which you have to learn at any cost. Without learning these laws, we cannot do a problem. So you cannot solve a problem. So learn these laws properly from the beginning. I forgot to tell one thing, that is in the indices law, that is the second law. So we'll have one more thing I wanted to highlight that. I am adding here only, so you also write while writing only. Okay, so first watch the video, then you start writing. So sorry, I'm explaining your class this. Suppose if the note, if n is greater than m, what we have to do? I didn't told you, right? If n is greater than m, so how we are going to write? So that is one of the major thing you should understand. So we can say that the above law can be shown as follows. The above laws can be shown as follows. I'll give you example as I gave always. So example for this is 2 to the power 3 divided by 2 to the power 5. 2 to the power 3 divided by 2 to the power 5. So now n is greater, m is lesser. So in such a case, it is very simple. You have already learned, whenever greater and lesser comes, what we used to do? Divide. So divide by what? 1 divided by 2 to the power 5 minus 3. So that comes to 1 divided by 2 to the power 2. So the ultimate answer 2 2s are 4. So 1 divided by 4 is the answer. Clear? So if you want one more example, I'll give one more example for this. I'll write it here only. Suppose the example is 4 to the power 3 divided by 4 to the power 6. 4 to the power 3 divided by 4 to the power 6. So if that is the case, 1 divided by 4 to the power what? 6 minus 3. Correct? 6 minus 3. So that comes to 1 divided by 4 to the power 3. So that is equals to 4 to the power 3. How much? 4 1 the 4. So the 4 2 the 8. And then 8 4. So if you go on 4 to the power 3, if you go, so you are going to get 64. 1 to the 1 divided by 64 is the answer. So multiply 4 4s are 4s are 2 4s are how much? 16. 16 4s are 64. Okay, so that is going to be your answer. Remember this. So laws of indices is very important. So today I have already explained you like how indices works, the laws. So what are all you are supposed to learn. So you have to understand this and write neatly in a 200 pages notebook, so that will solve the problems from tomorrow application level problems. Okay, so and learn this laws as well. So without laws we cannot solve any indices problems. Okay, I'll come back soon with problems. So till then, take care. Goodbye. See you soon. Stay home, stay safe, take care of your family. Bye.